Welcome to qnawire.
All right. So in this problem, we have the circuit shown here. So we have the capacitors. This is in series and this is in parallel. So the two ends, this is A, this is B. All right. And we have the capacitance for these capacitors as this is 8.6 microfarads. So for the rest ones, the unit, they are all the microfarads. All right. I just use number to label them. This is a 4.8. This is 6.2. This is 11.8, and this is 3.5. So we also know that the voltage across AB, VAB, is 12 volts, okay, according to the problem. So we want to find out the total energy stored in the circuit. So if we want to find out the total energy in the system, we need to figure out the equivalent capacitance of the circuit, okay? So firstly, these two, they are in parallel, they're in series, right? So if you have a capacitors connected in series, you have expression 1 over C, like 1, 2, equal 1 over C1 plus 1 over C2, right? So this is the, so C1, if C1, C2 for C1, C2 being connected in series. And in that, by using this formula, you can see that the equivalent capacitance for these two equal 8.6 times 4.8 divided by 8.6 plus 4.8, which equal 3.08 microfarads, okay? So this is the equivalent capacitance for the first two. And the equivalent capacitance for these two are given as 6.2 times 11.8 divided by 6.2 plus 11.8, all right? So this gives you 4.06 microfarads. And because we also have the parallel connection, and for the parallel connection, this is the series, okay? This is C1, C2. If we have parallel connection, so parallel connection, okay? Then the total capacitance C1, 2 simply equal to C1 plus C2, all right? Then, so come back to this circuit, you see that the equivalent capacitance for these two is 4.06. So plus 3.5, this gives you the equivalent capacitance for the whole loop, right? So which gives you 4 point. No, I use the other page. Let's say the parallel connection. 4.06 plus 3.5. This gives you 7.56 microfarads, right? And then this one is in series with the whole loop, right? So we have the equivalent capacitance given as C equal 3.08 times 7.56 divided by 3.08 plus 7.56, all right? So this gives you 2.19 microfarads. So it means that the total equivalent capacitance for circuit is 2.19 microfarads. And because we already know the total voltage across this C, which is 12 volts, right? So we can determine the total energy, which equal half C times V squared, right? So C is the one that we found here, and the V is 12. So the energy is 158 microjoules, all right? So this is part A. And part B, we want to find out the energy stored in this resistor, okay, in this capacitor. So the charge for the total circuit is Q equal C times V, right? So C is the one that we found here, and the V is 12. So you can find out the charge. And then if you look at the circuit, you see that the charge stored on the whole circuit equal to the charge stored on this capacitor. stored on this capacitor, right? Because it is in series. So in that case, we can determine that the the total energy of this stored in this capacitor equal E equal half Q squared over 4.8 microfarads, right? So this will be the energy stored in the 4.8 microfarads. So this actually gives you 71.8 microjoules, all right?